So, hello everyone. So this is my audio voice recording of stem in milk jugs. And I figured it'd just be easier to be able to submit a PowerPoint itself that you could go through and look at your own time, and then also just the voice audio recording. So basically, the overview of this project is that you're taking an everyday product or tool and you're pulling out STEM concepts for it and figuring out how STEM is involved in the designing, functionality, and just overall use of the product. So let's dive right in. So first I want to start off with an introduction. My name is Morgan Staub and I'm an elementary education major at Fort Hays. I am a senior this year and I plan to student teach and graduate in the fall 2024 semester. So the innovative technology that I will be discussing today and pulling STEM concepts from are milk jugs. And then this is a video about how milk jugs get their shape. So we're going to watch that really quickly. And then, of course, I am not able to get it to go on screen recording. I don't know why. Like this. But it's only about 30 seconds long. It just shows you the process. And I will go through and kind of explain how that process is done when we're doing, when we're talking about how they're made. I'll pull concepts from this video. So I'll show you kind of parts to keep an eye on. So right here is like the finished mold of the milk jugs. And then over here, this is really important to pay attention to because I'm going to pull an example from this later on. And so we have that video. Really quick, just kind of a good introduction to milk jugs. So let's dive into the science. So scientific makeup refers to materials and the chemical composition that's used in the production of milk jugs. So milk jugs are primarily made of HDPE, which is a polymer that has a linear structure tightly packed with molecules, and it's mostly made of carbon and hydrogen atoms. And HDPE also has low permeability to gases and liquids. So, additionally, some milk jugs also contain colorants and additives to enhance the quality of the milk, and I will get into that a little bit later. But the low permeability to gases and liquids just basically means that a lot of gases and liquids cannot get into the container once it's been made, but it also cannot get out unless it's been opened. So, chemical properties are also critical, or they are critical to ensure the milk jug's capability for storing and transporting the milk that it holds. So, HDPE is what is called chemically inert, and basically what that means is that it's not reactive to any of the content or materials or liquids that it holds. So this basically what it does is it just prevents those unwanted flavors from leaking into the milk. So milk can chemically react with certain things in our environment. I know that the sun also has effects on milk, which goes along with the coloratives and additives. But this is basically just to protect the milk and its quality. And then the polymer is also non-toxic, so it is approved for food storage. And the plastic is also hydrophobic, and that just stops moisture from getting into the milk and contaminating it. And then material properties also play a huge role in storing and transporting the milk. HDPE includes a lot of material properties, and some examples that I've been able to put down here are like recyclability, flexibility, high density, and impact resistance. And I will get into a few of those a little bit later on in the slides. But right here, this picture is what HDPE looks like in its natural form. A lot of the times we see it in building materials and structures. So this is just kind of what it looks like naturally. And I just wanted to include a picture of that so you guys would be able to see what it looks like. And so now we're going to get into the technology of milk jugs. So how are milk jugs made? So this is it's a simple yet complicated process. So milk jugs are usually created at a company's own dairy plant. They do not call in a third-party company and to have them create milk jugs for them. Usually the dairy plant just has a machine and they'll make the milk jugs their own and store them. But the machine that's used to make milk jugs is called an extrusion blow molder. and that is this picture right here. And so the molder typically takes the HDPE resin, which comes in that pellet form that I showed you on the last slide, and then it melts it. And then the melted resin then travels down this tube of heated plastic, and then the molds on the machine, which are right here, they clamp that heated plastic, and then the plastic forms into the shape of the milk jug after air is shot into it. And then so, again, I told you I was going to be pulling concepts from the video. That very last 5 to 10 seconds of it, you can see the milk jug go into something and then air is shot into it. And that is the process of the blow molder that is being showed in that video. And then so how do milk jugs function? So milk jugs are actually very practical, and they serve a lot of functions like storage, handles, size, durability, dispensing, volume measurements, sealing mechanisms, and transparency. And then fun fact, the indents on milk jugs actually allow a consumer to see if milk has gone bad. And I did not know this, so this was really cool to learn about, but these indents right here are not for design purposes. They're not for design or the look of the bottle. They actually have a purpose. And so basically what happens is when milk has gotten warm for too long of time, or it's about ready to spoil or go bad, it releases these gases. And basically once they've released the gases, the indent on the bottle, the gases will push the indent out. It's not a lot, usually at first. The only time you get a really big change in that indent is if the milk has spoiled and gone really bad. But basically with this indent right here is it'll push out. So the indent is curved inwards. So you should be able to curve your hand around it. So if you pick up a gallon of milk at the grocery store and run your hand along it and it's raised a little bit on that indent, it means that your milk is spoiled and you probably should not buy that milk. And then how have milk jugs evolved over time? We have this picture right here that I'm going to go over. But the first recorded milk container was actually the recorded one that we have was created in 1860 in Europe. But a fun fact is that the first record of milk being collected actually occurred in 4000 BC. So at this time, milk was being collected, but it was not used for food purposes. Back then, our digestive system had not evolved enough yet to be able to actually consume milk and break it down for energy. So milk was not necessarily edible. It was later on that we were able to do that, but it was collected and just used for other things around that time. But back to the containers that were first created. These containers were very large and they were made of metal. So the first ever one was just basically a big metal bowl that did not have a lid or anything like that. And then kind of over time, they evolved into these kettle things. And these are they can be recognized in older movies and stuff like that. But that was kind of how they evolved over time. And then in 1884, a man by the name of Dr. Thatcher invented the glass milk container. And then I have some variations throughout the years over here of the glass milk container. And this kind of allowed for this more sanitary storage of milk because the containers could be sealed. But they were easily breakable, and that irritated a lot of people at the time because if you dropped a metal bowl, worst case scenario, your milk is just going to spill out. But if you dropped a glass bottle, your milk would spill out and glass would break. So the pickup process was a little bit more in depth than it was with the metal container, and I know that irritated a lot of people. But then in 1915, John Van Warmer invented a paper container that could hold milk, and you can see that one right here. I know the picture is kind of small, but so this container basically, it just kind of made fewer messes if it was dropped. Is basically what the purpose of it was. And then a spout was later added to the container, and that made for easier pouring. And then finally, in 1963, Walter R. Bard created a design for a plastic milk container that we still use today. So they had screw-on caps, and it just kind of helped with accessibility and keeping out germs. And then that is this right here. So since 1963, we've made a lot of material advantages with milk jugs. with to improve like durability, sustainability, leakage, and function, like with anything. But the original design that Bard made is what we still use today for milk jugs. And then I just wanted to quickly go over, I know I went over already how milk jugs are made, but I wanted to point your attention to this picture. This just kind of gives you the steps. So it's heated, and then it's secured, and then it's stretched with a core rod, and then the air is pushed into the milk carton, and then the bottle is removed, and then it's finally finished for use. So the engineering of milk jugs. How do milk jugs work? So milk jugs are a pretty simple product. Just by looking at a milk jug, you can pretty much figure out how it works and its purpose and function. The jug itself is just used for the storage of milk. And the container is sealed, and it just holds and protects and keeps the milk safe from contamination, promoting its overall quality. And then the screw-on cap is just another quality measure. It just prevents air and water from entering the jug. And then the handle allows for the consumer to move the jug easily. So if you're lifting or pouring, milk can be kind of heavy, so that handle really comes in. It's very... the handle is just good to use. Moreover, mainly milk jugs also have volume indicators. I have not seen a lot of milk jugs with volume indicators, but some do. And this just allows customers to see how much milk they have left in the product. And then the HDPE polymer just allows for the overall durability of the product. And then, so why do they work? So the screw-on caps on the jug itself just keep air from oxidizing the milk, and it just maintains freshness. But that's basically how it works. And then HPDE is a durable plastic, which decreases the amount of leaks that a milk container might have. And then here I'm getting into the light. If milk is exposed to light, chemical reactions can occur to the milk that can change basically the makeup of milk, like your proteins and your fats. And that kind of results in this sour, yucky taste of milk. And so light can actually be blocked by adding color. It's a simple fix to the HDPE resin, and it just helps the milk stay fresher longer. And then over here, this picture I actually got from an article. It talks about how if grocery stores are stocking milk jugs that are transparent, meaning you can see the milk inside the jug, the LED lights that they use in the grocery store are actually making the milk turn sour or expire faster. So I thought that was a pretty interesting read. So the link is down here if you wanted to read through that and get some more information about that. And then, is there something better? So there is a plastic out there called PET or PET, and it's used to package soda. And PET has gained a lot of popularity as an alternative material to packaged milk over the years, because it is very lightweight. And then, like HPDE does, it doesn't contaminate the product. But it's mostly gaining popularity because it's so lightweight. It's lighter than HDPE, so it would just go for an added bonus so milk wouldn't be so heavy when you get it from the grocery store. I know that the idea is more popular than the actual implementation of PET in milk jars or containers. And this is because of a design flaw. So PET is mostly used to package soda, and sodas do not come with handles. It's mainly just used for 2-liter bottles of soda, which is a very simple design to be able to hold the liquid that it contains. And milk jugs do need a handle to be able to operate and use. So I know kind of the idea is more popular because they couldn't figure out how to bend PET to make the handle and make it stay on the container and last. And then there's also glass bottles that are gaining popularity. Again, they're coming back because they're a little bit more sustainable and they keep the milk fresher longer than HPDE does. But I just wanted to point out there's pros and cons to every type of packaging. If I had to pick, I think HDPE does a pretty good job. It does everything that we want it to do for storing milk. So I think that's the best option that we have right now. If we had a biodegradable material that could be used to package the milk, that would be great. I know that HDPE can be recycled, but they have to melt it down and cut it up into flakes, and there's only certain flakes that can be used and recycled. They have to throw the rest of them out. So if we had something that was a little bit more sustainable and better for the earth, that would be a great benefit and something better than HDPE. And then the mechanics of milk kind of refer to those physical principles and basically all the consideration that goes into engineering and designing the product for functionality. And milk jugs are designed to withstand bending and compression. And then the polymer also has properties like strength and flexibility, which just makes it an overall good option for holding milk. And then screw-on caps also allow for airtight seals, and then handles allow for that secure grip when lifting and pouring. And then the jug itself is also designed with considerations for transportation, not just for the user. And that's impact resistance and stackability. And there are also seals for the user that are designed to break once the jug has been tampered with or open. So there's a little ring that is placed underneath the screw-on cap for milk, and once you open it, that ring becomes loose on the milk jug. So if that ring is loose when you go into the grocery store and pick up a jug of milk, it means that the jug of milk has been opened, and you should not buy that one. And then some innovative ideas that I thought of. I mentioned this one before, but like making them with biodegradable materials or designing a better handle for those with some hand mobility issues and can't really grip the handle that is already being used on milk jugs as well. And then I know that because light is soiling the milk, a lot of companies have switched to adding color or additives into their HDPE. So maybe just a transparent indicator so that you can view the amount of milk inside. And then maybe just using sustainable ink to print labels so that the process is a little bit better for the earth. So to get into the mathematics of milk jugs, there are the ratios that I was not able to find any. There are no ratios used within the production of milk. And then the ratios related to milk containers are kind of just expressed in like cooking, like a dilution ratio, which is used when you have to dilute the milk with water in cooking. And then for equations, we have the conversion of mass, which milk containers have to contain the same amount of milk that's indicated on their label. So that equation is P1A1V1 equals P2A2V2. And then 1P1 is the initial density of the milk, 1A1 is the initial cross-sectional area of the spout, and 1V1 is the initial velocity of the milk as it flows out. And then the same thing for the twos, except it's the final. So you're making the initial equal to the final and just solving for that. And then for pressure, the pressure at the bottom of the jug is also related to the milk above it, and that equation is P equals PGH, and where capital P is the pressure, lowercase b is the density of the milk, G is the acceleration due to gravity, and H is the height of the milk column. And then some formulas that I found would be surface area, which is calculation of the total area of the milk jug, which is suitable for size measurement. And that equation is 2 equals 2 pi RH, where A is the lateral surface area of the cylinder, pi equals is about approximately 3.14, and the radius R is the radius of the circular base of the cylinder, and H is the height of the cylinder. And then we have flow rate, which is the calculation of the rate that milk flows out of the container when poured. And that formula is Q equals AV, where Q is the volumetric flow rate, A is the cross-sectional area of the conduit or spout through which the milk is flowing, and V is the velocity of milk as it flows through the conduit. And then we have volume, which is the calculation of the volume of the milk inside the jug. And that is V equals pi R to H, where V is the volume of the cylinder, pi is approximately 3.14, R would be the radius of the circular base of the jug, and H would be the height of the milk jug. So to kind of wrap things up, I wanted to talk about what I learned. So mostly throughout this project, I kind of learned about the production of milk jugs, but I really wanted to highlight my research on mechanics. I had no idea about how much consideration goes into the engineering and design in everyday objects, and even just milk jugs, for it to be sustainable and productive for the user. Like the indents, the handles, the sealing capabilities, the screw-on caps, all of those are designed with the consumer in mind and the transporter in mind, just to provide functionality. And then all of those materials, they're specifically picked to contribute to the functionality as well. And I just had no idea how much STEM concepts you could pull out from a simple product like a milk jug. So for some of my historical findings, I enjoyed reading through the source about the timeline of milk jugs. It was a pretty simplified source. I didn't want to include too much so it wouldn't be overwhelming. But I really liked reading about how milk was actually first collected around 4000 BC. And then as time went on, those milk jugs evolved from like metal containers to glass bottles, to paper containers, and then to the plastic jugs we know and use today. And then, kind of my final reflection about this project, I really enjoyed this project, but it was a little stressful, if I'm being honest. It was very hard to find information about like the mathematics and the scientific makeup of milk jugs, and even like the steps to making milk jugs, because the companies do not release a lot of information about how they produce milk jugs in general. But it was still, so I had to search and hunt for all of those sources that I used, but it was kind of cool to figure out about all the functionality and purposes of milk jugs. And it was just really exciting to learn how much STEM concepts are just related to and involved in things that we use every day. I kind of have a new appreciation for the design and engineering that goes into things like pencils and milk jugs and cups, because they're all designed to be functional to the user. And then to end things off, I just have a list of all my references. So thank you for listening. And I appreciate your time.